Welcome pre-cal students to the homework help video. Let's go ahead and get started and help you with some of these homework problems, okay? Let's go through. Notice the steps are right here for you. We're going to graph numbers 13 through 31. So let's go ahead and get started. Determine the end behavior. All right, we have an odd degree, a negative lead coefficient. If you've studied your notes, you know that means that it will go up to the left and down to the right. All right, step 2, find the zeros and plot these. So I put a 0 in for my y. And now I solve. Well, I'm going to factor this left side. Always pull out what's common first. I can pull out an x squared, and because this right here is negative, I'm going to pull a negative down like this, and then I'm left with x plus 2. Let's make sure that's right. Negative x squared times x, negative x cubed, negative x squared times 2, negative 2x squared. Now be careful on your multiplicity. Notice you have a squared. So you really have negative and then x, and then x plus 2. Okay? So for this group here, if you set this group equal to 0, you would get a 0. If you set this group here equal to 0, you would get a 0. And if you set this group here equal to 0, you would get a negative 2. You do have two zeros because of the x squared, so be very careful. So we're going to go ahead and plot these x-intercepts, 0 and negative 2, like step 2 says to do. Then step 2 also says to check for multiplicity. Well, these two zeros here, I have two of these, and that's an even number. So the multiplicity of the negative 2 is 1. The multiplicity of the 0 is 2. And so that's an even number. So this x-intercept right here is going to be a tangent intercept. That means the graph's going to come down and hit and go back up. Or if it's down here, it's going to hit and then go back up. Okay? So don't forget that 0 is going to be one of your special x-intercepts. Okay, moving on to step 3, find the y-intercept. Okay, easy enough. Everywhere there's an x, we put a 0. Well, if I put a 0 here, I get a negative 0. If I put a 0 here, I get a negative 0. So it looks like y equals 0. And I've already got that point plotted right there. Okay, so find the y-intercept. We've done that. Moving on to step 4. Now, before I start picking x values in between the x-intercepts, let's first of all just use a little bit of common sense here, okay? I know the graph has to go up this way to the left. I know it has to hit here. Let's see if that makes sense. It's probably going to hit here, and then it's probably going to come back up somewhere, and this is tangent right here, so it's going to hit here and then start coming back down again. And that's perfect, because if you'll think about it, guys, the degree's 3, so the maximum number of turns it can take is 2, and there's your 2 turns right there. And you know it has to be going up that way and down that way. So I think we're looking pretty good here with our idea. So that kind of helps me know where to plot some points. For example, I'm not too worried about plotting a point up here somewhere. I know the graph is going to shoot up and not come down again. And I know it's not going to do anything like this, take some different turns, because it's already taken its 2 maximum turns. What I need to know is what this graph is doing at negative 1 right here. Okay? So I'm going to plug in or substitute negative 1 into my equation, and you will get out a negative 1 if you do that correctly. A negative 1. So I know the point, there's a point right there. Now, it could go lower, it could come down and go a little lower and then curve up, but I'm not that picky. I just know that the point in between these two zeros is right here. So I'm going to come down, I'm going to hit here, I'm going to curve back up and curve there and then curve down like this. And that's it. I mean, we did it. There's no need to plot points over here and see where we're at, or over here, because we know it's going to shoot up and keep going up because of my end behavior and down because of my end behavior. Let me get a drink here real quick. So usually as we do step 4, we always end up sketching the graph. Now let's check and make sure everything's good. Well, we know the maximum number of turns is 2, and it only takes 2 turns. We know the maximum number of zeros is equal to the degree 3, and I do not have more than 3 zeros. I have 2, so everything looks good. Moving on to number 15. All right, number 15, we'll start off by determining the end behavior. So here we go. Degree is odd, lead coefficient is positive, and so with that in mind, we know the graph's going to go down to the left and up to the right. On to step 2, find the zeros and plot these, and then look for multiplicity. Okay, put a 0 in for your y. We're going to pull out what's common, which would be an x cubed, and you would be left with x squared minus 4, I believe. Let's check and make sure. The x cubed times x squared, x to the 5th, x cubed times negative 4x cubed. Now we can factor this a little further. For x cubed, I'm going to go ahead and put 3 x's so we know, so we're not confused about our multiplicity. And then over here I would have x plus 2, x minus 2. Very good. So I'm going to find my zeros. This group here would give me a 0, this group is 0, this group is 0, this group here a negative 2, and this group here a positive 2. So there's my zeros. I have a 0 at 0, a 0 at negative 2, and a 0 at positive 2. Now, multiplicity. I only have one of these and one of these. I have 3 of these, and that's not an even number. So none of these x-intercepts are special. None of them are going to be a tangent x-intercept, okay? So done with step 2. Step 3, find the y-intercept. Well, it's going to be 0. I mean, everywhere there's an x, you put a 0. Put a 0 here, you get a 0, minus. Put a 0 here, you get a 0. 0 minus 0 is 0. So my y-intercept is 0. Okay? Remember, when you're finding the y-intercept, you put an x, you put a 0 everywhere there's an x. Okay? Now, we're going to pick x values that lie between the x-intercepts and evaluate these. Now, before I do that, let's just kind of get an idea of what we're looking at. We know the most number of turns this graph can take is 4, 1 less than 5. So I know I'm down here. I know I have to go down this way. Let's say it hits here, and then hits here, and then hits here. Now that's only 2 turns, okay? So I'm a little concerned that it might do some more turns somewhere. And you might say, well, Mr. Eric, that's not possible. If it turned again, it would hit the x-axis, then come back up. And that would be 4 turns, which is fine. You're allowed to have 4 turns. Well, it could do one of these things where it does a little turn like this or something like that. So I want to make sure I'm accurate. So first of all, I'm going to put in, see this point right here, I'm circling it for you, negative 1, and this point here, positive 1. I'm going to put those 2 numbers in just to find out what the graph's doing. That's what step 4 says to do. It says to pick values between your x-intercepts. So I already have this into my table of my graphing calculator, my table of values. And negative 1 is going to give you out a 3, and positive 1 is going to give you out a negative 3. Okay? So negative 1, 3, and positive 1, negative 3. Okay, so that's pretty good. So far we know the graph's going to more than likely kind of look like this, and then come down here through this x-intercept, hit here, and then come up here. Now here's where it becomes a little long, the problems, but I'm going to go ahead, and that's why here at Graphing Calculator does help a lot. I'm going to go ahead and look at numbers 3, 4, 5, and 6 and kind of see what the graph's doing. Well, if you look at your table of values, you can see it's just going up, 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 and up like crazy. So it's not coming back down. So it's not making any more turns. I mean, 3 gives you out 135, 4 gives you out 768, and 5 gives you out 2,625 way up here. Now let's go the other direction, look at some of our negative numbers, and it's the same thing. Negative 3 gives you negative 135, negative 4 gives you negative 768, and negative 5 gives you negative 2,000 way down here. So it's obviously shooting way down like this, okay? Now, that's the best. Sometimes there can be some little curves right here, a couple turns or here, but for me, that's definitely sufficient. I mean, that's all we're trying to do is just get a basic idea of the graph. So we sketched the graph. The maximum number of turns is 4. It only took 2, so we're fine. Maximum number of zeros is 5. We only had 3, so that's fine. Okay? All right, let's move on to number 17. They've already factored it for us, so that's helpful. Step 1 says, oh, it's actually not very helpful. I'm going to show you guys a little bit of a trick here, okay, that will really help you. We've got to determine the end behavior, and we can't determine the end behavior until we have first written it in standard form. Well, if you'll make sure all of your groups have your x terms first, and if they're all binomials with this monomial here, that's fine. Think about it. If I took x times x and x minus 4, think about this. I'd be left with x squared minus 4x, okay? And then times x plus 1. Well, the highest exponent you'll get is when you take x squared times x. That will give you x cubed. All your other terms are irrelevant, because remember, to write this in standard form, you want to know what is the highest power, and I can do that without doing all the multiplication. So when I took this group times this group, my highest power was an x squared. Now I take this group times the next group, my highest power will be an x cubed. And then when I take this group times x minus 2, this is my highest power in this group. This here is my highest power in this group. When I multiply those, I will get x to the 4th. So that's going to be pretty easy to see. I'm not going to write it in standard form, but I know my highest degree is going to be x to the 4th. Now, is my lead coefficient going to be positive or negative? Well, this x here is positive, this x is positive, this x is positive, this x is positive. So when you're multiplying x times x, you got x squared, then x squared times x, that's another positive. It is going to be a positive. Now, if you did not understand what I said on a test or a quiz, unfortunately for you, you might have to go through and do all the multiplication, which can be done relatively quickly. It's not too bad. You would have x squared minus 4x, and then multiplied by this group here, you would have x cubed, and then a negative 4x, and then you would have, let's see, a positive x squared, and a negative 4 would be a negative 3x squared, and then take this group here times the last group, x minus 2. And when you do that, you'll get a real long polynomial function. That's fine. But either way, or you can try to do it a short way like I've done it. Either way, you're going to come up with the degree is 4 and the lead coefficient is positive. So that means the graph's going to go up this direction and up this direction over here to the right. Now, let's move on to step number 2. Step number 2 says determine the zeros, which is going to be easy to do. They've already factored it for us, and plot these. So I have a 0. This group here would give me a 0. This group a positive 4. This group a negative 1. This group a positive 2. There's no even multiplicity, none at all. And 1 0 would be here at negative 1. Another 0 would be 0. Then over to 2. Then over to 4. Now find the y-intercept and plot it. Okay, let's put a 0 in everywhere there's an x. This shouldn't be too hard to do. Y equals, I'm going to put a 0 in for x right here, and then 0 minus 4 is negative 4, and then 0 plus 1 is 1, and then 0 minus 2 is negative 2. Now when you multiply all these numbers together, you're obviously going to get a 0, because I don't care what all three of these numbers are when you multiply them together. In the end, you're going to multiply it by 0, which will give you out a 0. So 0 times negative 4 is 0, times 1 is 0, times negative 2 is 0. So your y-intercept in this case will be 0. Okay? All right, moving on now to step number, whatever it was. Let's see, step number 4. Let's pick some x values that lie between the x-intercepts and evaluate these. Now, first of all, I want to point out to you we have no tangency, so I know the graph probably is going to be going up this way. It's going to hit here, come back up, hit here, come down, hit here, and then come back up. Now that looks pretty good because they're both going up to the left and up to the right. I used all 4 zeros. I have 3 turns, and the most I could take was 3. 4 minus 1 is 3. My degree is 4. So that looks pretty solid there, but I still better find out where some of these values are. For example, I want to know exactly what the graph is doing between 0 and negative 1. between 0 and negative 1. So I'm going to substitute into my function negative 1/2, okay? And you will get out a negative 2.8. Alright, so at negative 1/2, we're down to negative 2.8. So approximately right there. Did not mean to do that. Let's do this. So negative 1/2, negative 2.8. So about right there. Alright. Now, I would like to know what the graph's doing here at positive 1. So I'm going to go to my table. I'm going to look at positive 1. And it looks like positive 1 is giving you out a 6. So if I substitute, let me write this in here, if I substitute 1 in, I would get out a 6. So over 1, up 6. And then I want to know what the graph is doing between these two zeros here at 3. And my table of values says the ordered pair would be 3, negative 12. 3, negative 12. So over to 3, and then way down here somewhere like this. Okay, so that looks like the graph is going to do something like this. I'm just kind of sketching it, estimation. Then it would hit here, come up. Notice all your turns are smooth rounded turns. They're not going to have corners. There we go. And, not sure why it did that, and if you look, it matches everything perfectly. The maximum number of turns you can have is 3, 1, 2, 3. The maximum number of zeros you can have is 4, and I have 4. Everything's perfect, okay? And if you have a graphing calculator and you hit graph, it'll look just like this, okay? All right, on to number 19. Number 19. Okay, determine the end behavior. Well, we have an even degree and a negative lead coefficient. That means we're going to be going down to the left and down to the right. Find the zeros. Okay, where the y is, I put a 0. Always pull out what's common. I can pull out an x cubed because the first term is negative. I'm going to pull out a negative x cubed, and I'm left with x plus 2. Let's make sure that's right. Negative x cubed times x would give me a negative x to the fourth, and negative x cubed times 2 is a negative 2x cubed. So we're doing pretty good there. Now, let's go ahead and find our zeros. Really, I have a negative, then x, 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 and then x plus 2. So I have 3 zeros, 1, 2, 3, and then 1, negative 2. So my x-intercepts, or my zeros, will be at 0, and then, excuse me, negative 2. Now, when I check for multiplicity, I notice I have 3 zeros and 1 negative 2. None of those are even numbers. The multiplicity is not even, and so I do not have any special intercepts that are tangent. Okay, so next, moving on now to step 3, find the y-intercept and plot it. Okay, well, that's easy enough. If I put a 0 in here for x, I get a negative 0. Put a 0 here, I get a negative 0. 0 minus 0 is 0. So my y-intercept is 0. That's already plotted for me. Moving on to number 4. Now, the graph we know is going to be going down. Okay, and it's going to hit here and then come down. Now, that looks good, okay? That looks good. But sometimes these graphs do some weird things like this. Sometimes they'll be coming down, and up here they might do something like this, like that, or anything like that. So I'm going to make sure here on this. I'm really going to check and make sure that I have everything correct. So first thing I want to do is I want to check what number? Probably negative 1, because that's right in between my two zeros right there. So let me quickly go to my grapher and get the right value here. Negative 1 gives you out a 1. Okay, so when we're at negative 1, we're then at positive 1. Okay, now again, the graph looks pretty solid, like it's going to go up and hit and then come right back down. But I'm going to make sure. I'm going to plot some values over here to the right. I mean, I know for sure it's going to come up and do this. That's pretty good. I'm not going to plot any fractions like negative 1/2 or negative 1.5. However, I am going to see what 1, 2, and 3 do. Okay, so I'm going to my table of values right now, and 1 gives me a negative 3. and then 2 is a negative 32. So it's almost like it comes down a little wider and then hits here and then starts shooting straight down. I wouldn't call that a turn right there, but I'm just describing it for you. And then 3 gives you out a negative 135, 4 is negative 384, so we're pretty good. It's going down and down. Now I'm going to evaluate the function at negative 3, and let's see what it's doing at negative 3. At negative 3, it goes, okay, at negative 3 it goes way down to negative 27, and then negative 4 is way down to negative 128, so it looks like this one's pretty much going to go straight down. Now, if you type this into a grapher and hit enter, you will see there's a little bit of a kind of a little dip-de-doo here thing, and that's fine. Again, we're just sketching it. This is totally sufficient. The main thing is we're finding the zeros, checking in behavior, Y-intercepts, all of that. Okay, so let's make sure everything's fine. The maximum number of turns is 3. It does not take more than 3. The maximum number of zeros is 4, and it only has 2 zeros, so we're good. Okay, moving on to number 21. Number 21. Now, let's go ahead and find the end behavior. And again, if this is one of the problems that you would struggle with because it's hard for you to just kind of picture the lead term in your head, then unfortunately for you, you might have to multiply all of this out, and that's fine. But to be honest, guys, I'm telling you, if you'll take this x times this x, when you take this group times this group, you get out a positive x squared for your highest power. And then when you take positive x squared times this group, there's an x right here, you would get out a positive x cubed. And then when you're all done doing that, there's a negative 1/2 out front, so you'd really have a negative 1/2 right here. So your lead term would look just like this. There's your lead coefficient. Now again, if you struggle with that, then very quickly you can square x plus 1, and that would give you, a trinomial x plus 1 times x plus 1, then multiply that times x minus 2, then multiply that times x minus 1, and then times negative 1/2, okay? But I'm telling you now, this will be your lead coefficient, so you're going to have, oh, and actually there's one other thing I forgot to do, and this can happen sometimes when you're doing the shortcut like this. When we write all of this out, notice it's negative 1/2 x minus 2, and then notice it's x plus 1 twice, okay? And then x minus 1. So really, and I apologize, you would have x times x is x squared, times x is x cubed, times x is x to the 4th. So really, what you're going to have for your lead coefficient would be this right here, okay? So, end behavior. Notice my degree is even and my lead coefficient is negative. So that means I'm going to have a graph that's going to go down to the left and down to the right. Okay, now step 2, find the zeros and plot these. Okay, no problem. This group here would not give you any zeros. This group here would give you a positive 2, this group a negative 1, this group a negative 1, and this group a positive 1. Alright, let me grab a drink here real quick. So there's your zeros. Let's plot those, okay? We know at negative 1, we're going to have a 0. At positive 1, we're going to have a 0 and positive 2. Now notice the multiplicity of the 2 is a 1, the multiplicity of the 1 is 1, but the multiplicity of the negative 1 is 2, and that's an even number. So negative 1 is one of my tangent x-intercepts. So this x-intercept right here is special. Okay, the graph's either going to come down and go like this, or come up and hit it and go back down. One of those two scenarios. So don't forget, negative 1 is one of my tangent x-intercepts. Okay, let's find the y-intercept and plot it. Everywhere there's an x, we're going to put a 0. So here we go. I would have y equals negative 1/2 times, put a 0 in for x, you would have a negative 2 here. Put a 0 in for x, and you would have a 1, and that's squared, and then put a 0 in for x, you would have a negative 1. Well, we can figure this very quickly. I mean, we have really negative 1/2 times negative 2, square your 1, 1 times 1 is 1, times 1, times a negative 1. Okay, negative 1/2 times negative 2 is a positive 1, times 1 is a positive 1, times 1 is a negative 1. So my y-intercept is at negative 1. All right. Now again, in order to find the y-intercept, everywhere there's an x, you put a 0. Now let's pick some x values and between the x-intercepts. Now before I do that, I'm going to kind of get an idea. It looks like the graph's going to be going down. It's going to hit here. It should go up. That's my tangent one right there, isn't it? Negative 1 is my special x-intercept. So it will not continue up and then come down. It will not do that. It's going to hit here, come back down. I'm not sure. We'll find out later. I'm not sure how far down, if it would come down, like hit here and then go back up, or if it would come up, hit here, then go down, then hit, then come up, then come down like this. I'm not sure. We're going to find out. We're going to plot some of these points. But that's pretty much, that looks like a pretty good picture of the graph, okay? So here we go. Let's first of all, I have a 0 at negative 1 and 1. So if I want to pick a point between those two zeros, it would be 0, but I already have that order pair. Remember, when I put 0 in, I get out a negative 1. It's right there. So you know what I'm going to do? I'm going to do something I don't do very often. I'm going to pick a negative 1/2. I'm kind of curious as to what this graph is doing right in between here, okay? So I'm going to go ahead and substitute a negative 1/2 into the equation. And when I do that, I get out a negative 0.5. I rounded that, so negative 0.5. So negative 1/2, negative 1/2. So it looks like it's going to be here. I'm going to go ahead and check what the graph's doing over here to the left. Negative 2, negative 3, negative 4. So I'm going to go to my table very quickly. And it looks like it's shooting down like usual. Negative 2 is negative 6. Negative 3 is negative 40. Negative 4 is negative 135. So it looks like the graph is shooting down like I thought it would do. So it's going down like this. Hits here, curves, hits here, comes back up. And now I'd like to know what the graph is doing between 1 and 2. So I'm going to put in 1.5. Okay? And when you substitute 1.5 in, you'll get out 0.8. So a positive 1.5 gives you out a 0.8. So that's barely up to here. So I'm going to go ahead and assume it's going to hit here and then curve and then start coming back down, okay? And if you hit graph on your graphing calculator, if you've typed this function in, you'll see that's exactly right, okay? We're right on the money on that. So there we go. Not too difficult. And let's continue. Oh, let's do our check here. Maximum number of turns would be 3, and we take 1, 2, 3 turns. Maximum number of zeros is 4, and we have 3 zeros, so we're totally good there. Okay, let's move on to number 22 or number 23. Excuse me. Let me get that entered into my calculator here. And we are good. Here we go. All right, now on this one here, be very careful. The last time I made a mistake when I forgot to write all the multiplicities out, so let's be careful here. We would really have g of x equals a negative x, and then x minus 1, x minus 1, and then x plus 4, and then x plus 4. All right, so I've written all of that out. That'll be a little easier. Let's see if I can slide this down here and have this replace it. Should be able to do that. There we go. All right, now step 1, determine the end behavior. Well, look. If you took this group times this group here, you would get an x squared for your highest degree. And then take x squared times this group, the highest degree you would have would be a 3. And then if you took x cubed times this group, the highest degree you would have would be a 4th. And then don't forget there's an x over here, a negative x. That would give you a negative x to the 5th. Okay? Negative x to the 5th. Now, again, if you have to do all the multiplication part, that's fine, but that would be a shortcut way to find the lead coefficient. Now, let's determine the end behavior. My degree is odd, my lead coefficient is negative, okay? So if it's odd and negative, that means I'm going to go up to the left and down to the right. If I can get this thing to work. All right, there we go. Now step 2, find the zeros. Okay, that's easy. For this group here, I would get a 0. For this group here, I would get a positive 1. For this group here, a positive 1. For this group here, a negative 4. And for this group here, a negative 4. So I would have a 0 at 0, a 0 at 1, and a 0 at negative 4. Now, notice I have a multiplicity of 1 for the 0, but the 1 and the negative 4 are they both have multiplicity of 2. There's 2 1s and 2 negative 4s. So both of these x-intercepts here and here are going to be tangent x-intercepts. So please don't forget that, okay? All right, moving on now to step number 3. We're going to find the y-intercept. Well, everywhere there's an x, I'm going to put a 0. Well, guys, you know it's going to be 0 because this x right here is going to give me a 0. Watch, I have a negative, then a 0, and then 0 minus 1 is a negative 1, and then 0 minus 1 is a negative 1, and then 0 plus 4 is 4, and then 0 plus 4 is 4. Everywhere there's an x, I put a 4. But when you multiply all these numbers together, in the end, you're going to multiply by 0, which makes the whole thing become 0. Okay, so the y-intercept is 0, and we already have that plotted right there. Okay, moving on to step number 4. Now, here's where we kind of pick some x values between the x-intercepts. Now, I know the graph is going up over here. I'm going to kind of assume it's going to be going up. This is one of your tangent x-intercepts, so it's probably going to hit here, come back up, I'm assuming, hit here, come down, and then be tangent here, and then come down. That's an assumption I'm making. That fits pretty well. I mean, I have 1, 2, 3, 4 turns, and the maximum number of turns I can take is 4. It's going up to the left and down to the right. So that's just kind of an estimation. Let's see what happens here, okay? Let's go ahead and pick a couple points. Here's a 0 here, negative 4. I'm going to see what the graph is doing very quickly at negative 5 and negative 6 over here. Okay, just kind of curious. So let's go to my table very quickly here, and negative 5 and negative 6, well, it really takes off. Negative 5 is 180, and negative 6 is 1,176. So I definitely know the graph's going to be going upward over here until it comes down and hits this x-intercept here, then it's going to come back up. Okay, next, let's see what the graph is doing at negative 1, negative 2, and negative 3. All right, so negative 1, negative 1 will give me out a 36. Negative 2 will give me out a 72. And then negative 3 would give me out a 48. Now, students, think this through very quickly. Negative 1 is up here at negative 36. We'll say that's right here. And then negative 2 is negative 72. That's way up here somewhere. And then negative 3 starts to come back down. Okay, so I don't expect you to graph all of that on a test or a quiz. You can just kind of go way up high on your paper. Just go way up high and maybe make a note somewhere on the test, like put these ordered pairs off to the side and say these are the ordered pairs for the graph, so I know that you knew that. And then come down here and we're going to hit right at 0. Now I want to know what the graph is doing between 0 and 1, so I'm going to substitute 1/2 into the equation. And when I do that, I get out a negative 2.5. I rounded that, but when you put in 1/2, you get out a negative 2.5. So at 1/2, we're down to about right here. Okay, so the graph's probably going to come down here, hit this. Remember, we know this point here is tangent. So I'm going to hit here, and then I guess I could see what's going on at 2, 3, and 4, but I'm 99% sure it's just going to shoot down like this because we know it has to end going down to the right. And so I'm pretty sure my graph is accurate there, okay? So, looks pretty good. Maximum number of turns is 4, and it takes 1, 2, 3, 4. It takes 4 turns. Maximum number of zeros is 5. We have 3 zeros, so we're totally within our limits there. Everything's fine, okay? All right, number 25. Now, I personally think it's going to be helpful to write this out. So I'm going to put f of x equals x minus 2 squared, so I'm going to put x minus 2 twice. And then x plus 1, that's 4 times. Now it's important that I do that because remember, I'm trying to find my lead coefficient and I don't want to make any mistakes. So I'm going to go ahead and put x plus 1 4 times. Alright, there we go. Now let's find the end behavior. Step 1. Well, if I took this group times this group, I would get an x squared for my highest term. X squared times this group would be an x cubed. X cubed times this group would be an x to the fourth. X to the fourth times this group would be an x to the fifth. And x to the fifth times this group would be an x to the sixth. Also notice that all of my x's I'm multiplying are positive x's, so I should get out a positive x to the sixth for my lead coefficient. Now again, if you have to do all this multiplying, I feel bad for you. I'm telling you, you need to really get used to this shortcut, okay? But either way, this will be your lead coefficient. So my degree is even, my lead coefficient is positive, so I know the graph is going to be going up to the left and up to the right. So step 1 is done. Step 2, determine the zeros or find the zeros and plot these, okay? I have a positive 2 for this group, positive 2, a negative 1, a negative 1, a negative 1, a negative 1. Now the multiplicity for these zeros here would be, there's 2 of them, and the multiplicity for these zeros here would be 4, there's 4 of them. So 2 is an even number, check. 4 is an even number, check. So all of your zeros, one of them is at 2, and the other one is at negative 1. All of your zeros are going to be tangent zeros, all of them, okay? So don't forget that when we go to sketch the graph. Okay, moving on to step 3, find the y-intercept, okay? Everywhere there's an x, I'm going to put a 0. So I would have 0 minus 2 is negative 2 squared. 0 plus 1 is 1 to the 4th power. I put a 0 here, and I put a 0 here. Well, if we simplify, negative 2 squared is a positive 4, 1 to the 4th power is 1, and 4 times 1 is 4. So I know that my y-intercept is going to be 4, okay? And that's very helpful. Now moving on to number 3. I'm going to pick some x values between these x-intercepts and kind of see what's going on. Before I do that, I know the graph's going to be going upward this way. It'll be continuing up. It's probably going to hit this tangent x-intercept, come up here, hit this tangent x-intercept, and then come up like that. I can only assume. That looks like a pretty good guess, okay? So let's see what happens here. First of all, I'm going to plot some numbers here to the left, negative 2 and a negative 3 to see what the graph's doing. So I'm going to go to my table of values. And it's like I thought, negative 2 is going up to 16, negative 3 is way up at 400. So the graph is definitely shooting upward over here like we thought it would, and we know the graph is tangent here to this 0, so it's going to hit and come back up. Now I know what the graph is doing at 0 right here. I know I have the ordered pair 0, 4, right? That's the y-intercept. But how about at positive 1 right here? What is the graph doing at positive 1? Well, let's find out. If we look at our table of values, we'll see that positive 1 is way up here at 16 somewhere. We'll say it's up here. And so on a test or a quiz, you could put that point off to the side like this right here. So that way I know that you found that point, and just stick it up here somewhere. So we know it's going to come up and shoot up pretty high. And we're going to assume it's going to make a turn there. That's good enough. And we know it's going to start coming back down to this 0 right down here. And we know it's tangent, so we know it's going to hit here and then start going up. I'm going to go ahead and check what the graph does at 3, 4, and 5 on my table of values, and it's probably shooting up. Yeah, at 3, it already goes up to 256. So, I mean, it's going basically straight up in the air. Okay, so there we go. We have graphed it, and let's go ahead and do some checks here real quick. Number of turns is 1, 2, 3, and the most you could have was 5, so we're good there. The maximum number of zeros was 6, and we only have 2, so we're good there. All right, number 27, and we're almost done, guys. 3 more of these, and then we'll get into the easier homework. Okay. All right, number 27. I think it's always better to write out the function very quickly. So g of x equals a negative, and then we're going to put x minus 1 4 times. And now let's go ahead and do step 1, determine the end behavior. Okay, well, we'll worry about this negative sign later. It's like having a negative 1 right there. If you take this group times this group, the highest exponent would be x squared. Take x squared times this group, the highest exponent would be x cubed, and then x cubed times x, your highest exponent would be x to the fourth. However, you then multiply that by the negative 1 out front, and so you would end up with a negative x to the fourth, negative x to the fourth for your lead coefficient, all right? Or your lead term, excuse me. Okay, so your degree is even and your lead coefficient is negative. That means the graph will go down to the left and down to the right. Okay, step 1 done, just like that. Step 2, find the zeros. Okay, they've already factored it for us. Positive 1 for this group, positive 1 here, positive 1 here, positive 1 here. Your multiplicity would be 4. That is an even number. So we know this 0 of 1 is going to be a tangent intercept. A tangent intercept, okay? So I know I have a 0 at positive 1. So we're going to go ahead and put that right here, and that's done. Now let's find the y-intercept. Okay, no problem. Everywhere there's an x, we're going to put a 0. So y equals negative. Here's an x right here, so I'm going to put a 0. 0 minus 1 is negative 1 to the fourth power. Well, you do your powers first, and negative 1, bring down your negative sign here. Negative 1 to the fourth power is a positive 1, and then a positive 1 times a negative 1 we give you a negative 1. So your y-intercept is going to be at negative 1. Okay, now here's where it gets interesting. Pick x values that lie between the x-intercepts. You only have one x-intercept, so we're probably gonna pick some numbers over here and see what the graph's doing, and then pick some numbers over here and see what the graph's doing. But more than likely, it's pretty obvious. I think the graph's going to be going down like this and hitting here. We know it's tangent there, and then going down like that. Okay, now but remember, it can take turns. I mean, it could do some really weird stuff. It could actually hit here and do a little dip-de-doo there, and maybe here and then down. Of course, it can only take 3 turns at the most, 4 minus 1, but you get my point. We got to be careful. So let's go ahead and look at our table of values and check out negative 1, negative 2, and negative 3. Well, it looks like negative 1 is going to give me a negative 16. So already at negative 1, I'm way down here. Negative 2 is at negative 81. So it's obviously going down. Okay, I can see that. Because I only have one x-intercept, I'm going to do something I don't usually do. I'm going to go ahead and see what the graph is doing at 1/2, right in the middle right there. I'm just kind of curious what it's doing. So let's put in a positive 1/2, and you will get out a negative 0.1. So at positive 1/2, we're at negative 0.1. So it looks pretty good. We're just going to go like that. Hit there. We know it's going to curve back down. Now I'm going to see what the graph's doing at 2, 3, and 4 on my table of values just very quickly. And it's like I thought. 2 is at negative 1, and then 3 is negative 16, 4 is negative 81, so it's definitely shooting straight down. So it's basically like a parabola. Okay, so there we go. Let's check this real quick. Number of turns had to be, maximum number of turns was 3, it only took 1 turn. Maximum number of zeros is 4, it only had 1 0, so we're looking really good. Moving on to 29. Okay, we finally get to do some factoring here, but first of all, let's determine the end behavior. My degree is 3, my lead coefficient is positive, so that means I'm going to be going down to the left and up to the right, just like that. Okay, so taken care of. Step 2, find the 0, so I'm going to have to put a 0 for h of x, and then factor this. I'm going to factor this very quickly. We should know how to do this by now. I'm going to pull out an x squared out of the first 2 terms. That leaves me with an x plus 3. And then over here I'm going to factor out a negative 1, and that's going to leave me with an x plus 3. If we write our common parentheses once, that's going to be x plus 3, and our other parentheses would be x squared minus 1. However, we know that we can factor x squared minus 1, and so we're going to do that. And if you factor x squared minus 1, you're going to get x plus 1 and x minus 1. Okay, now let's find the zeros. For this group, I would have a 0 of negative 3. For this group, I would have a 0 of negative 1. For this group, I would have a 0 of positive 1. the negative 3 has a multiplicity of 1, the multiplicity of negative 1 is 1, and there's only one positive 1, so we have a multiplicity of 1. So none of these zeros are going to be my special tangent zeros. So I'm going to go ahead and plot my x-intercepts, negative 3, negative 1, positive 1. So there, I've plotted those. And now let's go ahead and look at step 3. Step 2 is completed. I did the in behavior, found the zeros, checked for multiplicity, find the y-intercept, okay? Everywhere there's an x, I'm going to put a 0. So 0 cubed is 0, 0 squared times 3 is 0, minus 0, and then negative 3. So if you combine all those, you will get a negative 3. So we know the y-intercept is negative 3. And now we're on to step 4. Let's pick some x values between the x-intercepts and kind of figure out what's going on. Before I do that, I want to get a rough idea of the graph. I know it's going to be going down. It's probably going to hit here, come down, hit here, and go up. That's a pretty good guess as to what the graph's going to look like. And it fits everything. I mean, the maximum number of turns I can take is 2, 3 minus 1, and the turns are 2. Maximum number of zeros are 3, and I have 3. It's going down here, it's going up over here. That looks like a pretty good guess, but let's make sure, okay? I'm going to go ahead and see what the graph is doing to the left over here at negative 4 and negative 5 on my table of values. And as you can see, or as I can tell you, wow, I mean, 1, 2, 3. At negative 4, actually, I might be on the wrong equation on my calculator. Hold on one second. I think that I am. Yes, I am. So hold on one second, please. I'm glad I caught that. Okay, here we go. At negative 1, 2, at negative 4, it's already at negative 15, way down here. And then at negative 5, it's negative 48, and so on. So I know it's going to shoot down. I'm pretty confident it's going to be shooting down over here like I thought. Now, let's see what the graph is doing at negative 2, right here at negative 2. All right. Well, negative 2 on my table of values says 3, so 1, 2, 3. So I could say I'm pretty confident it's going to come up and hit here and then come down to this intercept here. And I already know what the graph is doing at 0. Remember, I have this 0, negative 4. This is the y-intercept right here, or 0, negative 3, excuse me. So I know the graph's going to come down and hit here and start coming back up. The only thing I want to make sure of is I want to really quick look at my table of values for 2, 3, and 4, and I think we're pretty solid there. I mean, 2 goes up to 15, and 3 is at 48, and then 4 is at like 105 way up here. So we know it's going to shoot up pretty quickly. All right, so there we go. Not too difficult. Let's check everything real quick. Number of turns is 2. That's the maximum number I could have. Maximum number of zeros is 3, and I had 3 zeros. So we're looking pretty good. Okay. All right, let's take a look at our very last one here, and we're finally done. So with the graphing part, and then the last 4 problems are pretty fast, pretty easy. Okay, so good job on this homework assignment. I know it's not been easy. I know it's been time consuming. Okay, here we go. Let's go ahead and find the end behavior. I have an odd degree and a positive lead coefficient, so that tells me I'm going to be going down to the left and up to the right. Step 2, we're going to find the 0, so we have to factor. So 0 equals, well, I can pull out a 2 and an x squared, okay? And if I do that correctly, I'm left with 3x minus 4. All right, let's make sure that's right. Multiply these together, you get 6x cubed. And 2x squared times 4 would be negative 8x squared. So we're looking good there. Okay. Now, I'm thinking you want to find the biggest number that goes into these two numbers. Let's see. 18 times 3 is 54, and 18 times 4 is 72. So the largest number that goes into both of these numbers is 18, plus there's a negative sign here, so I'm going to pull out a negative 18. If I do that correctly, I am left with 3x minus 4. Negative 18 times 3x is negative 54x, and negative 18 times negative 4 is positive 72. So I'm doing pretty well here. My matching parentheses would be 3x minus 4. And my other matching parentheses would be 2x squared minus 18. Now I can factor this second parentheses again. It's going to take a little bit of work, so watch carefully, please. And by the way, I really made a mistake. It's not going to hurt anything, but really I could have started this whole factoring off by pulling a 2 out of everything. That would have made all these numbers a lot smaller. But we can do it this way. This is fine. 3x minus 4. Out of this group right here, I can pull out a 2, so I'll put a little 2 right here, and that leaves me with x squared minus 9. And now I can factor x squared minus 9 into x plus 3, x minus 3. Okay? Now, this looks a little weird, a little unorthodox, and the reason it looks a little weird is usually you have your whole numbers out front. So I'm going to take this 2 right here, and I'm going to move it out front like that, which is fine to do, and then put this back up here. So there we go. And that's why I told you at the beginning we could have pulled a 2 out of this, and it probably would have made it easier. That's my fault. And then it would not have been as complex with such big numbers. But anyways, this will work also. We factored our 2 out already, so we're good to go. Now, I'm done factoring. Now let's find the zeros. For this group here, there would be no zeros. For this group here, it would be 4/3 or 1 1/3. For this group here, it would be a -3. For this group here, a +3. There's no multiplicity that I have to worry about. So my x-intercepts will be at -3, +3, and then 1 1/3. So there's your zeros right there. Okay? All right, let's go ahead and move on. Step 2 says to find the y-intercept and plot it. All right, so everywhere there's an x, I'm going to put a 0. So y equals, well, 0 cubed times 6, 0, 0 squared -8, 0, 54 times 0, 0, and then 72. So I don't have really room to put a 72 on here, but off to the side, if you were taking a test or a quiz, you would want to let me know that you know that this ordered pair, let me get a drink here, does exist on the graph. So you know you're way up here on the y-axis, way up here somewhere, okay? All right. Now, let's continue on to step 4. We know the graph's going to go down, and we know we have no tangency, so I'm going to kind of get a picture of this graph, just a quick sketch. It's going to be going down. It'll probably hit here, turn, hit here, turn, hit here, and go up. I'm assuming it's going to do something like that. Okay, that's a pretty good guess. That fits everything. My degree is 3, so the maximum number of terms is 2. Turns is 2, and I took 2 turns. Maximum number of zeros is 3. I've got 3 zeros, so I just did step 6 out of order. So everything checks there. So the only thing I have to do now is substitute some points in, and then kind of see what I get. So I'm going to real quick, I'm going to make sure I'm on the right graph, and I believe I am. Scroll down here and make sure I'm on the right graph in my graphing calculator. Yes, I am. Okay, so I'm going to look at what the graph's doing at -4, -5, -6, and it's just going way down. I mean, boom, straight down, trust me. So I know the graph's going to be way down here, and it's going to hit here. Now, what is the graph doing at 0, -1, and -2? Well, let's find it. Well, I know what it's doing at 0. 0 is way up here at 72. Let's see what the graph is doing at -1 and at -2. So let's substitute -1, and if you do that correctly, oh wow, you'll get 112. If you put -2 in, you'll get 100. So this thing is basically going straight in the air. I mean, -1 is way up here at 112. So as long as you have these points written off to the side so I can see them, that's good enough. So the graph, we know it's just going to go straight up here somewhere. I mean, way up high, and it's going to hit your x-intercept up here, or your y-intercept up here, and then start coming down. Okay, and I'm not worried about you plotting that many tick points. Okay, this is totally fine. So we know it's going to hit here, and we know it's not tangent there, it's going to come through. Now, what is the graph doing at 2? Okay, let's see what it's doing at +2. At +2, the graph is -20, so it's way down here. So again, almost straight down. So in your notes, as long as you put 2, -20, I know you found that point. So it's going to be way down here, and then it's going to come up and hit this point here, and then it's going to go straight on up. Okay? Now, Everything looks good, but we've already checked our number of turns, we've checked our zeros, the end behavior matches, so we're done, we're good. Everything looks really good. Okay, so that was a lot of work to do, and I know that. That was what, 13 through 31 odd, that's 10 graphs that we did. That's a lot, but at least they're done and we're moving on. Now we have 4 problems, these will go pretty quickly, okay? Alright, what I'm going to do is take my graphing, take a calculator, and everywhere there's an X, I'm going to put a -5 in, okay? So let's do this very quickly. In fact, some of this I can do in my head. What I'm going to do, they want to know if in the directions for 33 through 39, they want to know if a 0 exists between these two numbers. So what I'm going to do is I'm going to substitute -5 in, and I'm going to substitute -4 in. Remember, this is called the intermediate value theorem, okay? Now, everywhere there's an X, I'm going to substitute -5 and get out a Y value. So -5 to the third power is -125. -5 to the second power would be positive 25 times 3 would be positive 75. And then -9 times -5 is a positive 45. And then minus 13. Well, let me grab my graphing calculator real quick and type these in. -125 plus 75 plus 45 minus 13. I'm getting out a -18. Okay? -18. Alright, now let's substitute -4 in for X. So -4 to the third power would be -64. And then -4 squared is 16 times 3 would be positive 48. And then -9 times -4 is a positive 36, and then minus 13. Alright, so very quickly, if I type these in, I would have a -64 plus 48 plus 36 minus 13. And you would get out a positive 7. A positive 7. Okay, so let me put this here. Now watch, look at your Y values. Did you have a sign change between your two values? Yes, one is positive and one's negative. Then that means there is a 0 between your two X values. So you know there's a 0 between -5 and -4. So yes, there's a 0 between -5 and -4. Now I'm going to check my answers. I always check them in the back of the book. So I'm going to pause the video here. Okay, I'm back, and yes, that's totally correct. So there is a 0 between -5 and -4. Okay, moving on to number 35. I am going to try to save a little bit of time by not doing all this work for you, because students, we are pre-calculus students, and you should know how to very easily on your own substitute a -3 in and get out a number, and substitute -2 in and get out a number. So I am going to save some time and not do all those steps for you. Okay, all right, here we go. Let's see if a 0 exists between -3 and -2. So I'm going to substitute -3 in and get out a Y value. Then I'm going to substitute -2 in and get out a Y value. Okay, now if you substitute -3 in, you will get out a 22. Hopefully you did that correctly. And if you substitute a -2 in, you will get out a 5. Now I have a question for you. Is there a sign change between the two Y values? Well, no, there's not. They're both positive. So please don't say this. Please don't put no 0 exists between -3 and -2. You can't assume that. All that you can say is it can't be determined, because a 0 could exist. It could be one of your tangent zeros. Okay, but we're not for sure. So we say it can't be determined. We don't know for sure if a 0 exists between -3 and -2 because there was not a sign change. Okay, so we do not know for sure. All right, number 37. All right, we're going to substitute 2 into the equation and get out a Y. Then we're going to substitute 3 into the equation and get out a Y. And we're going to see if a 0 exists between 2 and 3. Okay, so let's see here. If you substitute 2 in, you will get out a positive 2. And if you substitute 3 in, you will get out 57. Now, I have a question for you. Is there a sign change with your two Y's? Well, no, they're both positive. If they were both negative, there would not be a sign change. One has to be positive and one has to be negative. Now, so because there's no sign change, we cannot determine anything. So we're going to have to say that the 0 can't be determined. Can't be determined. Okay? We do not know. There could be a 0 between the 2 and the 3, and there might not be. We just don't know for sure. And then lastly, number 39. We're going to substitute 4 into the equation, and we're going to substitute 5 into the equation. All right? If you substitute 4 in, you will get out a negative 12. If you substitute a 5 in, you will get out a 4. Is there a sign change between your two y values? Yes, there is. So we can say for sure, yes, there is a 0 between the x values 4 and 5. Now, where is that 0? I don't know. It might be 4.1, it might be 4.2, it might be 4.5, I don't know. But a 0 does exist between 4 and 5. Okay? So there we go. That's all you do with the intermediate value theorem is you substitute two x values in, and then you compare the y values to see if there was a sign change. Okay? I hope this homework help video has been a help to you. Call or email if you have any questions.